So, hi. This is my project. Right now I'm over in Vermont in the East Coast and I got this done and I'm really proud of it. As you can see, um, I'm doing the cosmic time and distance. I have it based around superheroes. I have Silver Surfer there, if you're familiar with Fantastic Four, and Star-Lord from Guardians of the Galaxy for cosmic. I did that because I thought just the project would be a lot more fun for me. And I'm gonna go into the universe, how it expands, how fast it does, things like that. So, first things first, the Big Bang. What is it? It's a theory that's heavily supported by scientists and is considered to be the start of the universe. It's relevant because of it's where dark matter and gravity came in from, which I'm gonna explain in a second. And the picture I have up here is Wolverine. He's walking away from an explosion, a big bang, if you will. And then we go on to how does the universe expand. So gravity and dark matter. I have plastic man over here for the expansion. And then I have dark energy that I'm going to talk about first. I have Raven over here because if you're familiar, she has a lot of dark energy powers. I thought it would be cool to add. So dark energy, scientists are, they're still discovering more things about it, but it's what covers most of a lot of the universe, and it's a very repulsive energy, the exact opposite of gravity. Because it's so repulsive, um, it pushes out the universe, it expands it. And it's called that. I added here because it does not reflect any light whatsoever. It's called dark energy because it fills all that dark void. And then going forward, the contrary is gravity. We know gravity is, it pulls things closer, and because it's the exact opposite of dark energy, it kind of regulates how far and how fast the universe expands. But it is weaker, of course, so they are doing a tug of war in that case. And then I wanted to go into how fast, if you know the Flash. I thought it was, perfect superhero for it. And then we go into what a megaparsec is. I realize this slide might have been a little long, but I wanted to explain it really in depth. So 1 megaparsec is about 3.26 million light years. Very big number. Astronomers use that because across galaxies, it's across galaxies. It is a very big number. So they use that to make it a lot easier. They don't have to use big numbers like billions of meters, of course. And and the universe actually has a speed of 67 kilometers or 41.6 miles per second per megaparsec. It's a big mouthful. I know NASA did some recent studies I was reading on the NASA website where it might be about 73, but for the sake of simplicity, I'm going to go with the 67. So going by per second per megaparsec, meaning it actually goes more into Hubble's law, which I can actually show you here. Hubble's law, in which the speed of how far planets are going, galaxies away, depends on how many megaparsecs. The further they are, the faster they go away. So something that is 3 megaparsecs away, which is roughly 10 million light years, would be going 3 times that, which is about 120 miles per second further. Sorry, it's really cold out in Vermont, so I got a little cough. And yeah, that's Hubble's law. It was discovered by Edwin Powell Hubble. He discovered it by in California going on I wrote it here, Mount Wilson, with a big telescope. And because of that, he was also discovered light sources, in which how he discovered how far it goes as well, which I'm going to go to in a second. That's a photo of him. I added too. Edwin Powell Hubble. So what he discovered, redshift and blue shift. The further a galaxy is away from where we see it, it's a lot more red, the light. That is because the wavelength of it is a lot more stretched out. And because of that, it's seemingly a lot more red. The exact opposite can be said with the blue light. The blue light is a lot shorter of a wavelength, so as the galaxy is closer, it'll come as a more blue hue, of course. And then in the photo here, I decided, if you're familiar with Red Hood and Nightwing, red and blue, I thought it was a cool little comparison and parallel to throw in there. And you can see in the middle is actually how the hue changes the further it goes, how it goes more red. And then I want to go into how old is the universe. I have the old Batman from the old Batman Beyond cartoon. I really liked that cartoon as a kid. Um, so the short answer is 13.7 billion years old. But this section is going to be like how we know about that. So we have cosmic microwave background. This is radiation that was spilled from the Big Bang that is still here today. And because it was distilled from the specific Big Bang, astronomers are able to look at that and find the exact age of the Big Bang based off that as a reference point. Also, off of that, we have black holes. Black holes, very common knowledge. They're when stars collapse, and they collapse in a way where the mass of gravity just sucks everything in, including light, which is why it's called a black hole. So astronomers are able to research the very old black holes, and since it's considered that black holes are formed in the galaxy they're in, they're able to base that as a reference point again of how old the universe may be. So they use that with the cosmic microwave background to look at all those things to know how old. The photo I chose for that is from the 2003 movie Hulk. When he goes big and strong, he has his shirt on, which expands because volume. Of course, black holes are heavy. So because they're so heavy, that's a lot of mass. With that mass in there, it's just more to pop out the universe. Like if you put a ball inside a cup of ice, the ice goes up, volume. And to summarize what I've explained that the universe expands due to the mass inside, so dark energy, including black holes like I just mentioned, and then how fast it is, so more into Hubble's law, the red shift and the blue shift, and how he discovered it to really establish that. And then despite the universe changing from its expansion, how astronomers are able to find fixed points like that cosmic microwave radiation, a mouthful, or black holes. So those were things that I wanted to use to give a good idea of what the cosmic time dilations and things like that for the universe. And I really wanted to go into for this project how the universe expanded, because I thought that was a really interesting concept. So I really hope you enjoyed it. If you liked superheroes, maybe some of those metaphors were cool to see. But yeah, I really hope you enjoyed it. But thank you.